Hello, everyone. This is in continuation with the various problems in testing of hypothesis. The next problem is a company is interested in considering two different TV advertisements, A and B, for the promotion of a new product. The management believes that advertisement A is more effective than advertisement B. Two test market areas with virtually identical consumer characteristics are selected. Advertisement A is used in one area and advertisement B in another area. In a random sample of 60 consumers who saw advertisement A, 18 tried the product. In a random sample of 100 consumers who saw advertisement B, 22 tried the product. Does this indicate that advertisement A is more effective than advertisement B? Use 5% level of significance. Now, first we will identify one thing is clear that it is a comparison between two different advertisements. Let us capture what are all given in the question. So, we say advertisement A, advertisement B. Okay, so one advertisement is tried in one area, another advertisement is tried in another area. Random sample. Advertisement A, it is 60 consumers. So, sample size 60 consumers. Out of that, 18 tried the product. Means I will say sample proportion. (18) out of 60 consumed the product or tried the product. In a random sample of 100 consumers for advertisement B, this is 100, and out of 100, 22 tried the product. So this becomes 0.22. This is sample proportion 2. So I will say P2 the cap. This is 18 means 3 by 6 3s are 6 10s are, so it is 0.3. This is our P2 P1 cap. This is N1. This is N2. Does this indicate that advertisement A is more effective than advertisement B or not? Means to test whether P1 is better than or larger than P2. So where I can say P1 is the population proportion of consumers who saw advertisement A and tried the product. B2 will be population proportion of consumers who saw advertisement B and tried that. So this is what we are supposed to test. So one thing is clear that the above is a test concerning with the above is a test concerning with population proportions. So since it is two population proportions and the sample sizes are large, we will go for a Z test. We will use Z test. Then next step is to freeze on hypothesis H0. H1, I can consider this what is to be tested as H1 because you do not have any equality sign. So that means H0 will be both the population proportions are the same. There is no significant difference between those two. P1 larger than P2. Since it is like this, it becomes a one-tail test. Now, Z, the relevant Z test statistic will be Z cal, that is Z calculated value that will be modulus of P1 the cap minus P2 the cap minus of P1 minus P2 population proportions difference under H naught divided by standard error. So from this I can say P1 minus P2 is 0 under H naught. So where standard error is equal to square root of P1 cap into 1 minus P1 cap. See, generally here we used to write only P1, that is population proportions. Since here population proportions are unknown, we are directly replacing that with the sample proportions. Cap 1 minus P1 cap divided by this whole thing under square. That means let us substitute now. P1 cap is 0.3. 1 minus P1 cap means it becomes 0.7 divided by N1 is 60 plus P2 cap, it is 0.22. So that means 1 minus P2 cap will be 0.78 divided by sample size 2 is 100. So if we evaluate this whole thing under square root, we get the value as 0.072. Now let us calculate that Z cal. Z cal under modulus will be modulus of P1 cap. P1 cap is 0.3 minus 0.22 minus this P1 minus P2 under H naught, we already know it is 0. 0 divided by standard error is 0.072. If we evaluate this, we'll get the value as 1.1. Now, Z tab is nothing but Z table value at 5% level of significance for a one-tailed test. This we know it is from the tables, it is 1.645. Now we can conclude with our inference. Since Z cal under modulus, which is 1.11, is lesser than Z tab, which is 1.645, accept H. That's the solution for this problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.